Welcome to the Watchdog timer of the HT8 MCU basic tutorial. This chapter will take you to understand the Watchdog timer of the HT8 MCU from the following 5 aspects: Watchdog timer introduction, Watchdog timer structure, Watchdog timer configuration, Watchdog timer reset, and Watchdog timer applications. Watchdog timer introduction. Do you know why the Watchdog timer is required? Let's take a look at an example of a fan module. In normal cases, after the power switch is turned on and the slow button is pressed, the fan starts to rotate. When the fast button is pressed, the fan speed increases. However, the fan may experience a crash during rotation. At this point, press the slow button or the fast button, the fan cannot rotate. In this case, the fan can only be restored by powering off and restarting. We press the button again and the fan rotates again. In order to solve the problem of MCU crashes, the designers added a Watchdog timer module inside the MCU. What is a Watchdog timer? The Watchdog timer, abbreviated as WDT, is a reset timer. How does it operate? First, set a reset time, which is the timeout period. The Watchdog timer provides multiple timeout periods for selection. Once the MCU is activated, the Watchdog timer starts counting. When the timer overflows, it will cause the MCU to reset. Therefore, in order to ensure the normal operation of the MCU, we need to reset the Watchdog timer in time before the reset time is reached in the main loop of the program to prevent an MCU reset. It should be noted that in the actual operation of the main loop function, different functions may be called, resulting in inconsistent execution time of the main loop. Please reasonably consider the Watchdog timer timeout period. This means that if the program is running properly, the Watchdog timer is reset before the main loop function has executed once and the reset time has been reached. If the program is not running properly, the Watchdog timer is not reset. When the reset time is reached, the MCU will be reset. Watchdog timer structure. Take the HT66F3195 as an example to understand the Watchdog timer structure. First, the Watchdog timer clock source is provided by the internal low-speed RC oscillator with a frequency of 32 kHz, which then passes through a divider to generate different timeout periods. The desired division ratio can be selected by the WS2 to WS0 bits in the WDTC register, which in turn determines the Watchdog timer timeout period. The minimum timeout period is 8 milliseconds, and the maximum timeout period is 8 seconds. 3 methods can be adopted to clear the contents of the Watchdog timer. The first is a WDT software reset, which is controlled by the WE4 to WE0 bits. The second is using the Watchdog timer software clear instruction CLR WDT. And the third is via a halt instruction. It should be noted that the WDTC register software reset will reset the whole MCU. Watchdog timer configuration. In the HT8 MCUs, the Watchdog timer is configured using the WDTC register. Taking the HT66F3195 as an example, how to configure the Watchdog timer timeout period to 512 milliseconds. First, we select a division ratio according to the timeout period. Then, we can set the WDTC register value to 01010011 using the program. First, the WE4 to WE0 bits are the Watchdog timer function control bits. When these bits are set to a value of 01010, the Watchdog timer function is enabled. Other values will reset the MCU. Second, the WS2 to WS0 bits are the Watchdog timer timeout period selection bits. Watchdog timer reset. In the HT8 MCUs, The status register is a status register, which contains the arithmetic, logical operation, and system management flags to record the status and operation of the microcontrollers. Using the register can check the status and operation of the microcontrollers. The TO bit is used to determine whether the Watchdog timer overflows. When the Watchdog timer overflows, the TO flag is set to 1. The PDF bit is the power down flag, which is used to determine whether the halt instruction has been executed to cause the MCU to enter the sleep or idle modes. When the halt instruction is executed, the PDF flag is set to 1. In different operating modes, the initial status of the Watchdog timer timeout reset is different. In normal operation modes, when the Watchdog timer overflows and resets the MCU will restore to its initial status. That is, the program counter PC is cleared, the stack pointer SP is restored to its initial status, and most registers are restored to their initial status values. At this point, the TO bit is set to 1, and the PDF bit retains its original status value. In the sleep or idle mode, a Watchdog timer timeout will wake up the CPU and only restart the program execution. That is, the program counter PC is cleared to 0. The stack pointer SP is restored to its initial status, and most registers retain their original status values. At this point, the TO and PDF bits are set to 1. It is worth mentioning that in low-power designs, the WDT timeout reset can be used to wake up the CPU from the sleep or idle mode to execute necessary tasks. Watchdog timer applications. In normal operation modes, the Watchdog timer is used to prevent the MCU from crashing. Take the running light as an example. Assuming the Watchdog timeout period is set to 512 milliseconds. The total time executed by the running light blinking from left to right is 384 milliseconds. Next, we will write the code as follows. First, enable the Watchdog timer and set a timeout period of 512 milliseconds. Then, in the while loop, we will implement the running flowing light program. The most important point is to add a clear Watchdog timer instruction before executing the running light procedure to reset the Watchdog timer. If the program is running properly, go back to the first step to clear the Watchdog timer, so that the MCU reset is not triggered. If the program is not running properly and the Watchdog timer cannot be cleared, then the Watchdog timer will keep counting and eventually overflow, causing the MCU to reset. For more details, refer to the application note HT8 MCU Watchdog Timer, WDT, application, crash prevention on the Holtec website. Course summary. In this course, we have learned about Watchdog timer function, principle, structure, WDTC register configuration, and Watchdog timer reset. Through the study of this course, you will have a certain understanding of the Watchdog timer. Holtec has a professional service team to assist in development design and after-sales service. Please feel free to contact our business departments for more detailed product information and consultation services.